Welcome back to the channel, students. I hope you had good learning experience. In the previous episode, we have been studying about the fundamental difference between speed and velocity. We have been able to cover different aspects of speed, and today we will study about velocity. As I've already told you that velocity is nothing but speed with direction. If we are considering only speed, we take only the quantity, the magnitude, the amount with, or you can say measurable numerical value of a physical quantity. And when a direction is also associated with it, speed with direction, we call it velocity. Now, fundamentally, you know the mathematical expression also. It is displacement upon time. Remember, speed was distance upon time. Whereas here we are taking displacement into account, means we are incorporating the concept of direction. So displacement upon time. Mathematically, we can even express it as delta x upon delta t. Delta x is change in position, and delta t is change in time, that is time interval. SI units, meter per second if it is SI, CGS, ECM, centimeters per second. Let us see different types of velocities. The first and the foremost, we are running on the parallel track. As we studied for speed, uniform, non-uniform, average, we will run on the same parallel track. Uniform velocity, non-uniform and average. So, uniform velocity, again, let us try to take it in a tabular form. Let us consider a situation where an object or the vehicle is in motion and we are trying to tabulate the distance covered with time taken. And you can consider an example like of a train moving with a constant speed in a straight line. Let us say we are keeping track of time and we have said in the first hour from the starting point of the journey, let us say the train, we are taking an example. So let us say it has covered 80 kilometers in 1 hour. Then suppose it is the boarding station, the time is 9 o'clock. 9 to 10, 80 kilometers. Next 1 hour, that is 10 to 11. Again next 1 hour, it has travelled or it has managed to keep up the same pace. Then next 1 hour, that is 9 to 10, 10 to 11, 11 to 12. I am taking the speed into account and let us say 80 kilometers in next 1 hour. This is how the train is moving. Now you will say, ma'am, this situation is more or less similar to what we have studied in uniform speed. Yes, you are right. If you have come to this conclusion, you are right. This should be what you can say the experience of a student when we are learning some topics or some concepts. In your brain, there should be continuous process of comparison, coordination, analyzing the situation. We should not try to attend a class in a monotonous blank without what you can say processing anything here in the CPU. We expect you to compare things, to make out the difference, to pre-locate what you have learned in the previous section, and all these things are a good sign of a student. So this part is similar, that there also we had equal time intervals and equal distances. Here also we are having in every 1 hour equal distances are being covered. But the point to be noted, the specific thing which I want your attention to be on is this type of motion is in a specific straight line. Here along with this magnitude part, magnitude means amount of distance upon amount of time. So it is 80, 80, 80, distance is same and magnitude of time is same, 1 hour time slots. This is magnitude part. Apart from this, there is a specification that this train is moving in a straight line. So magnitude plus direction, magnitude plus direction, these two in a what you can say combined manner are giving us the idea about velocity. So are you ready to define velocity? Yes. What you can say, uniform velocity is when a body covers what type of distances? 80, 80, 80. It's not fixed. You can take any other value, 90, 100, whatever suits you. Just an example. When a body covers, but all these values are equal. So, let us highlight the key terms. When a body covers equal distances, EQU, equal distances in, what can you say about the time intervals? Yes, equal time intervals. Is this sufficient? Is this complete? Yes, you are right. You have to include the direction concept also. When a body covers equal distances in equal intervals, in equal time intervals, in a specific direction or in a straight line. You say that the body is moving with uniform velocity. Repeating, when a body covers equal distances in equal time intervals, not stopping there, adding in a specific direction or in a straight line, then and then only you say that the body is moving with uniform velocity. Are you ready to move on to non-uniform velocity? Yes. Non-uniform or variable velocity. Here we can have variable velocity under three different situations. Like the first situation which may lead to variable velocity is when the speed of the body is changing but the direction is not changing. You can consider a situation, a vehicle on a road moving with variable speed but its direction is same. It is moving along the same straight line. So the point to be noted is speed of the body changes but direction remains constant. So distance traveled and time taken, tabulation. In the first hour the vehicle traveled 80 kilometers. Then in the second hour, as I told you, typical Indian road situation, the speed slowed down and it could cover only 75 kilometers. Let us say in the third hour there was little betterment of the situation. So again the vehicle could cover 79 kilometers in that third hour. Then again in the fourth hour its speed dropped down to 72 kilometers in 1 hour. That means in the first hour it could cover 80 kilometers. Second hour the speed dropped, that is distance covered in that 1 hour is 75 kilometers only. Then the third hour the distance covered is 79, it rose up. And again in the fourth hour the distance covered in the last 1 hour has dropped down to 72 kilometers. So what do you observe? Here the magnitude of speed, amount of speed or amount of distance covered in given 1 hour. Magnitude of speed or amount of distance covered in 1 hour, it's changing frequently from 80 to 75, 79, 72. It's not constant. But what is constant? Direction is same. It is along the same straight line. So when the speed of the body changes, direction does not change. Then also you can say it is variable or non-uniform velocity. This is the first situation which leads to non-uniform velocity. Second situation you can see, suppose a car or a cycle moving on a circular track. Yes, can you recall? So even you might have cycled in a circular situation. So here in this situation direction changes but speed is constant. Suppose you have chosen, I will cover this complete circle. Just see the circle. the point A, B, C, D. I have chosen some points and you have decided that I will cycle or I will run along the circular track or I will walk along the circular track. Whatever you have chosen, suppose you have decided I will run along the circular track with a constant speed of 50 meters per second. Means at the point A, speed is 50 meters per second. At the point B, it is 50 meters per second. C, D and all the other infinite points on the circle. So speed is 50 meters per second at all points of the circle. At all points of the circle, the magnitude of speed is 50 meters per second only, not changing. But what is changing? Evidently, you can see at the point A, the velocity is tangential at the point A. This you have to understand that whenever at any point you have to find the direction of velocity, you have to mark a tangent in the direction of motion. Suppose the motion direction is anti-clockwise. So the direction of tangent has to be in agreement with the direction of motion. What I can say, if I mark the tangent at the point A, then the tangent represents, what is it representing? Tangent represents direction of velocity at a given point. What is tangent representing? Direction of velocity at a given point. Suppose I want to know the direction at the point B. What should I do? Yes, I have to mark a tangent. Tangent means a line which touches the circle at one single point. You will learn more about tangents in your mathematics. So this is at a point B. Suppose I want to find out what is the direction of velocity. What I will do? Mark a tangent. So the tangent I have marked at the point B. Remember, tangent's arrow should be in agreement with the direction of motion. Suppose I want to know the direction at the point C. What should I do? Yes, I will make a tangent. What is tangent? A line which touches the circle at one single point. I have marked the tangent. Now what is tangent representing? Tangent is representing direction of velocity at the point at which I have drawn. Suppose I want to know the direction of velocity at the point D. Then what should I do? Of course, I will draw a tangent. Yes, at the point D. Now what is this tangent representing? Tangent is representing direction of velocity at the point D. So what is the situation here? Here the magnitude of speed is constant, but the direction is changing in each and every moment. Velocity is changing because even though the speed is constant, but direction is changing constantly. This also leads to uniform velocity. The third situation where both A and B can happen means the magnitude of the body is also changing, direction is also changing. If both are changing, then obviously the situation is variable velocity. So this is all about variable velocity, where speed changes, direction constant. Where speed is constant, direction is changing, or both speed and direction are changing. This will lead to non-uniform or variable velocity. Average velocity, the third category. We have already seen it is total displacement upon total time. Average speed was total distance. Here you have to consider total displacement. Means the difference between final position and initial position. Total displacement upon total time will give us average velocity. Let us work it on for a situation. Suppose you are at the point A. A is the initial point. Yes, A is the initial point and you are at the point A. And you have started your journey from A towards B. You have started your journey from A towards B and you have reached to the point B, and B is the final point. The radius of the circular track which you have chosen is R, isn't it? So first let us calculate. The initial point is A, final point is B. What is the average velocity if you have covered this distance in time t? So first case, average velocity, we denote it with the subscript V average is equal to total displacement. You move from A to B via this path. And you have already done it in distance and displacement in the previous episodes. We have done some numericals also. So from A to B you have moved through this path, but the displacement, which is shortest distance between initial point and final point, the shortest distance or the difference between final position and initial position is this, which is equal to the diameter of the circle. So V average will be total displacement. So the body or you got displaced from A to B. The displacement vector is 2r. So the total displacement is 2 times of radius. And what is the time you took to cover this distance? It is t. So average velocity is this. Now let us consider a second situation. Suppose you started from the point A and you reached again the same point A. So A is the final point as well as the initial point. Means you started at A, covered this complete circle and reached back to A only. So A is the initial point, A is the final point also. And you took some time, say T dash. So what will be the average velocity? V average. V is the capital letter and AVG is the subscript I'm using. So average velocity will be total displacement. Total displacement means you started from A, reached back to A only. The displacement is 0, or you reached back to your initial, the difference between final position and initial position is 0. So the displacement, total displacement 0 upon T dash, the time you took. So the answer is coming out to be 0 meters per second only. Got the difference? If suppose you are calculating average speed, then definitely you will be, if you are taking V average in terms of speed, then you will be definitely taking this complete circumference, that is 2 pi into r divided by the time. If you are taking speed, then you will take complete path length. This is total distance, which is circumference of the circle upon the total time. But if you are taking it for displacement, the displacement from A to A is 0 upon total time. So this is how the technically, or you can say application wise, these two concepts vary. And you have to do little more numericals, and if possible in the coming episodes we will do little advanced kind of concepts based on speed and velocity. But nevertheless, don't forget one big conclusion, important conclusion. Speed is always either equal to or greater than the magnitude. These two absolute lines, magnitude of velocity. This you have already seen, because speed is related to distance and velocity is related to displacement. So speed can be equal to velocity, speed can be greater than velocity. Speed can never be less than velocity. Let it be registered in your mind. Stay tuned in, stay connected, be regular. All the best. Thank you.